David Kriegman. I'm a professor of computer science at the University of California, San Diego, and I've been a professor now for almost 30 years. Really, it was computer vision and AI that came first for me. I was doing a lot of work in face recognition and physics-based computer vision. This is 10 years ago, before the deep learning craze started.
Yeah.
And some coral ecologists approached me, and they had a need. The problem was that they were going out in the field and gathering data about the health of coral reefs, and they'd spend 2 weeks in the field and then spend 6 to 8 months analyzing those images. And they knew that there's going to be 2 to 3 orders of magnitude more data coming. The reason for the more data was the way they were getting data originally was that scuba divers were going down and taking photographs manually. Now you fast forward to robotic operated vehicles, autonomous underwater vehicles, and those vehicles are running video and come back with 1,000 times more images per day, and they can run 24/7. And so the data deluge was coming, they saw that, and they approached me. That turned around as I learned about the plight and the fate of the reefs. I became more passionate about the application and how I can take my expertise in machine learning and apply it to this, and then take advantage of the fast changing technology. So, I mean, my primary job is as a professor, so I start the day after my morning exercise. I head into work, and it's all about the students, really. It's all about people. So whether I'm teaching a course or preparing to teach a course, I might be meeting with the students that are on a research project, or it may be meeting with students in my class. That's the primary focus. You sprinkle in with that of coming out to places like the summit right now,
Yeah.
being here or going out into the field. Sure. So the reefs are, I guess there's so many reasons why one should be concerned about it. For one, the reefs are like the rainforest, but of the underwater world. They only occupy 1/10% of the total ocean area, but they harbor 25% of the species that are in the oceans. So there's a huge amount of variety of life that is there. And so there's a lot of benefit that one gets out of that variety.
Yep.
Secondly, the reefs are producing, what they produce is coral. They produce calcium carbonate. The coral animal produces the stone. That stone is what protects the islands. Those islands would disappear if the reefs weren't there. And so, so as the corals die off, the ability for them to reproduce and reproduce calcium carbonate decreases, and then the shorelines are more threatened. Thirdly, about 250 million people live in the vicinity of the reefs in 100 countries, and there's a lot of economic livelihood that's associated with the reefs, whether it's fishing, whether it's tourism. Those are being impacted by the degradation of the reefs. So, so you drill down to something very, very specific that we're working on.
Yeah.
So, sort of data is everything. Being able to understand the state of something is how you can make actionable decisions. Whether you're a reef manager that's deciding how policy might change, whether you're actually complying with the policy, or even what the causative factors are, does agricultural runoff really contribute to a problem? If it's not so significant, maybe you don't want to change agricultural practices, but maybe if that's the dominant thing, you want to understand it. So, how do you understand the state of the reef? Well, the old way of doing it, the manual way of doing it, is divers would go down, they would take photographs. They might, in 2 weeks, get 1,200 photos. They would go in and analyze those photos in the lab. What I've tried to do in ours is to automate that process using deep learning techniques. And that in turn allows the researchers to go out and get more data, and then they can also begin to start using, let's say, robotic operated vehicles and get much more data. So that's the basic workflow, but I've built this out through a website called CoralNet, and CoralNet is a tool that sits online, runs on AWS, is open for all marine scientists to use. They can upload their images. They also have a choice to make those images public or private. By making them public, we now have an opportunity for sharing the data and making it more accessible, and in turn trade more powerful models, because we can now have this pooled data of, say, 30 million annotations versus a small 1,200 images that you might typically have in a single survey. So we can pool that data together. And our hope is that not only do we make something that's smarter, that the data itself becomes more readily shared. Time. Got to push forward. The situation is dire, so we want to act quickly. There are technical challenges that we're looking at, and so there's a suite of opportunities ahead of us. The techniques that we're using were based on categorization. They build off of a sequence of technical results that have emerged. There are additional methods like GANs that were talked about earlier today that can help us with domain adaptation that we want to do, so that we can work with less labeled data, but also pool the data together for domain transfer across domains. We want to do complete segmentation. We want to develop three-dimensional maps of the bottom so that we can get more accurate measurements. So if you want to know about coverage, is it a 2D problem in a 2D image and percentage of that image, or is it actually mapped onto the 3D seascape and what the bottom is really like? So to move from 2D to 3D and so on. So far we've been leveraging the work in other industries.
Yep.
Now, I've always kind of felt that in research, and I've done this in face recognition in other areas, that if you take a hard problem, it's going to generate new ideas that then have really broad applicability. So, I don't necessarily see the solutions immediately generalizing, but I do see that the research, because they're hard problems, will lead to something valuable and fruitful. With that said, while we call it CoralNet for only corals, people have used this stuff for analyzing forests. They've used it for analyzing underwater oil rigs. And so other places where the annotation methods are basically, the protocols are very, very similar, it's to direct usage. So it's applying the artifacts more than the deep learning methods. So we've just been fortunate to receive some funding from the Schmidt Ocean Institute, and they are helping us really be able to expand the reach of CoralNet. There's a lot that has to go into maintaining and expanding just the core infrastructure. It's a little bit like a startup. I'm a professor at university, this is all out of university research, yet there's some point where you have the same challenges and issues about growth and expansion, maintenance. So you build something out and suddenly you own it and people are depending upon you. It's not necessarily driven by economics, but it's driven by some of the same considerations. How do you build a product that's going to be used by other, provide the value to the end users? They're not customers, but they're end users in the way. And so what are the product features that are needed, and developing those out. And so this new infusion of funds is going to help with that. And then after that, we want to really build out some of the machine learning capabilities. Gosh, I don't think it requires much encouragement. I think there is so much demand for it amongst the young people that it's more how many do you need, and how do you make it equally accessible? I mean, accessibility might be a bigger challenge than actually bringing people in. By way of example, I teach the graduate level computer vision class at UCSD. 4 years ago, I had 35 students in that class. I went on a leave of absence. I was off in industry for 4 years. I came back, and day one of the class, I had a room that held 198 students and had 84 on the wait list. So there's no shortage of interest of students working on this. You could certainly say, how do you engage in computer science more women, more underrepresented minorities, and people of different backgrounds to be more diverse. And that's, say, a bigger challenge to bring them into the fold.